So for this first example, we have to decide for each figure, does the figure show a rhombus, a square, or a rectangle? So let's just quick, before we jump into the actual problems, let's think about what would indicate that we're looking at a rhombus, what would indicate that we're looking at a rectangle, and then what would indicate that we're looking at a square. So starting with a rhombus, we'd be looking for one of three things. Either we see that it fits the definition of a rhombus, like definition-wise, because it has all four sides congruent, and by definition it would be a rhombus. But then the other two things that we could look for would be those theorems that we learned that kind of show that a parallelogram would have to be a rhombus for other reasons besides the strict definition. One of those was if the diagonals were perpendicular, then it would have to be a rhombus. And then the other one is if one of the diagonals bisects two of the angles of the parallelogram, that would also indicate that it's a rhombus. So there's kind of three things we could look at there. We could look for all sides being congruent, diagonals being perpendicular, or a diagonal that bisects the two of the angles of the parallelogram. For a rectangle, we can look, there's really two things that we can look for that would indicate that we're looking at a rectangle. We could look either for the definition of a rectangle, which is that the four angles would all be congruent, or they would all be 90 degrees, or that the diagonals are congruent to each other. Those two things would indicate we're looking at a rectangle. Now, when it comes to trying to decide if we're looking at a square or not, it's a little bit trickier, because what we have to be able to show is that there's something that makes that shape a rhombus as well as something that makes it a rectangle. That's kind of the trick for deciding if it's a square. There's something that makes it a rhombus and there's something that makes it a rectangle, because a square is like a combination of a rhombus and a rectangle. It has all four sides that are congruent like a rhombus, and it has all four angles that are the same or 90 degrees like a rectangle. So knowing that, let's jump in and take a look at these four diagrams. If I look at A, and I look at what information is given to me, what are the clues in this picture, it's that all four parts of the two diagonals, right? Each diagonal is split into two parts. So we got these four different parts of the diagonals, and they're all fives. 5 from here to here, 5 from here to here, 5 from here to here, and 5 from here to here. What that indicates, what that's trying to show us, is that these diagonals themselves are congruent. The entire diagonal here is 10 units long, and this entire diagonal is 10 units long. And congruent diagonals point towards a rectangle. So our answer here is that this is going to be a rectangle, and the reason is we're going to say it has congruent diagonals, just to kind of give us a reason why we know it's a rectangle. In part B, we'll notice that the clues are that we have a bunch of 45-degree angles here. So I have one diagonal drawn in my shape, splitting this angle into 45 and 45, and this angle into 45 and 45. And so we can see right away that there's something there that tells us that this is a rhombus, because one of the things we just talked about is if one of the diagonals bisects two of the angles, then it has to be a rhombus. So I look at this and I say, okay, this is a rhombus. But if I think a little bit more about what these angles would have to be, I might actually have a better answer than just saying it's a rhombus. Because if I look here, 45 and 45 together would make 90. So this angle is 90 and this angle is 90. And we know that this is a parallelogram. Because it's a rhombus, it means it's also a parallelogram. And that would indicate that this angle would have to be supplementary to both this one and this one. So in order to be supplementary to those two angles, this angle right here has to be a 90-degree angle. And if that angle is a 90-degree angle, then the one across from it is also a 90-degree angle. And so we can actually see here that we have something that makes this shape a rhombus. The diagonal is bisecting two of the angles. But we also have something that makes it a rectangle. In fact, we have the definition of what a rectangle is. All four angles are 90 degrees. So since this is both a rhombus and a rectangle, we will say that this is a square. Okay, it's a square because it's a rhombus with the diagonals bisecting two angles, and it is a rectangle because all angles are 90 degrees. So we've shown that it's both a rhombus and a rectangle, meaning that it's going to be a square. Option C, or diagram C over here, we'll see again that this diagonal is bisecting these two angles here and here. This angle's been bisected because these two parts are congruent. This angle's been bisected so these two parts are congruent. So I know right away this is a rhombus. Now what about these? Why are these important? Well, this would actually be another way that we can tell this is a rhombus, because again, the instructions are kind of calling out, saying, look, this is a parallelogram. Can you go farther and say that it's a rhombus, square, or rectangle? Well, if it's a parallelogram, then we know the opposite sides would have to be congruent. So these opposite sides, the opposite side from this one would have the same mark, the opposite side from this one would have the same mark. So now we can see that, hey, look, all four sides are congruent, which is the definition of a rhombus. So there's kind of like two things here that indicate that it's a rhombus. Is there anything that indicates that it's a rectangle? Do we know that all the angles are 90 degrees? Well, not necessarily, because we know that these two parts are congruent, but we don't know, like we did over here, that they're both 45 degrees. Same thing here. We don't know that these are both 45 degrees, making this a 90-degree angle. They might be 46 degrees apiece. They might be 44 degrees apiece. We don't know exactly. And we don't know anything about this other diagonal, so we can't use the second thing that would make it a rectangle, that the diagonals are congruent. We can't use that because we don't know anything about this diagonal. So all we can say here is that this one must be a rhombus, because we can either say all sides are congruent, or we can say that one diagonal bisects two angles. Okay, so for either one of those reasons, that's got to be a rhombus. Now in option D here, we got to think, all right, what do we have? We have just these two markings, that this part of this diagonal is congruent to this part of this other diagonal. But remember, it's telling us that this is a parallelogram. And since we know this is a parallelogram, we know that the diagonals are actually bisecting each other. So these other two parts would have these same markings, because each diagonal is cutting the other one into two congruent parts. And so now we can see something that looks an awful like what we had in A, that we don't have the actual numbers, but we can see that whatever measurement this is right here, it's the same thing for all four of these parts of the diagonals. So if this is 5, that's 5, that's 5, and that's 5. If this is 4, that's 4, that's 4, and that's 4. So in either case, we can say that the diagonals of this shape are going to be the same length when you put them together, so that makes it a rectangle. This is going to be a rectangle because it has congruent diagonals. And now we're moving on to the second example, and it asks what value of x right here would make this parallelogram have to be a rhombus. So this x, what would it need to be in order for this shape to be a rhombus? And one of the things we can remember is that if a shape has diagonals that are perpendicular, then it's got to be a rhombus. So for this shape to be a rhombus, this needs to be a 90-degree angle right there. And so now we can look and say, well, what measure of x would force that to be a 90-degree angle? If we want that to be a 90-degree angle, then these two angles need to have a sum of 90. So in order for all three of those angles to add up to 180, or for the two acute angles to add up to 90, we need to say that x plus 36 needs to equal 90. Again, because if these two add up to 90, then that makes that have to be a 90-degree angle, so that they all add up to 180. And so now if we just subtract 36 from each side, that x would have to be 54 degrees. And there's our answer. That's what x would have to be in order for this to be a 90-degree angle, and therefore for these diagonals to be perpendicular, which would make this shape a rhombus. Now for our last example, it says if the measure of angle 1 is 36, let's go ahead and kind of draw that in here. We'll say that this is 36 degrees, and the measure of angle 2 is 54 degrees. Is PQRS a rhombus, a square, a rectangle, or none of these? So, okay, what do we have to go on here? Well, it says that these opposite sides are parallel to each other, and we have a couple angle measures. We know that if this angle is 36 degrees, then this angle over here would also be 36, because those two angles are alternate interior angles, and I have two parallel lines crossed by this transversal here, so those alternate interior angles should be congruent. So this angle right here would also be 36 degrees. And now if I take 36 plus 54, I get 90 degrees. Well, why do I want to know what those two add up to? Because if those two add up to 90, these two add up to 90, then that leaves this angle right here to also be 90 degrees. Reason being, if I take 180 minus 36 minus 54, I get 90. And now that's got to be that angle right there. So I got a right angle. So I can tell right away that this thing is a rhombus. At the very least, it's a rhombus because its diagonals are perpendicular. So now the question would be, is there anything that says that it has to be a square? In other words, can I also prove that it's a rectangle? I already know it's a rhombus. Can I prove that it's also a rectangle, which would make it a square? Well, let's see. What else would I know? Would I have any information about what this angle would be right here? Any information about that? Actually, yes. I know what that angle is. It's going to be 36 degrees. Because once this is a rhombus, it means that these diagonals are bisecting the angles of the rhombus. So this diagonal segment PR, it's bisecting angle QRS and angle QPS. So this angle right here would also be 36 degrees. This one would be 36 degrees. This angle here would be 54 degrees. And then these two angles are both 54 degrees. So, can this be a rectangle? No, it can't, because 36 plus 36 makes 72 degrees. This angle, in order for it to be a rectangle, would have to be a 90-degree angle. It's only a 72-degree angle, so it can't be a rectangle. And if it can't be a rectangle, it can't be a square. So our only answer is that this is a rhombus.